All right, 6.7, probability and odds. First thing I want to talk about is just, what are some of the general terms, all right? You don't have to write all of this down. We're going to read some of these here in a minute. I just want you to look at a few of these terms here. Outcomes, for example. Well, an outcome is when I'm actually testing out whatever it is, whatever type of experiment I'm doing. So if I'm testing results of rolling a die, the actual rolling of the die produces an outcome. If I'm looking at card examples, well, actually drawing a card and the card I get, that's an outcome. All right, an event is the outcome or the collection of the outcomes. Okay, so again, this is just a bunch of terms that are going to make more sense in a minute. This is a big one, a favorable outcome. What are we trying to test? For every card I draw, I'm looking to see how many hearts I draw. Okay, so I'm looking for hearts. That would be my favorable outcome. For every die that I roll, I'm trying to roll a 3. So 3 would be my favorable outcome. You can almost view it as like a goal. Okay, favorable outcomes. So all in all, what is probability? Probability is the likelihood that an event will occur. Okay, so I'm measuring the likelihood that an event is going to occur. And I use this formula. Probability of an event occurring is favorable outcomes over possible outcomes. And we could probably label this theoretical probability. They talk about it after this example. But this is theoretical probability. We'll explain in a minute the difference between theoretical and experimental probability. All right, so we're going to add in a word here. Theoretical probability. Here's what it means. I'm going to explain it a little bit more, and it'll make a little more sense in a minute. Theoretical probability is when you know how many possible outcomes there are going to be. It's very predictable. For example, a number die. Okay, dice. How many sides are there to the number dice? 6. Will there ever be a different number of sides? No. It's just 6. Okay, well, in a standard die. No. There's 6. Okay? So that is predictable. How many cards are in a deck of cards?
52.
52. That number never changes. In a deck of cards, there's 52. So a theoretical probability, I know what the possible outcomes are going to be. I know that number. With experimental probability, that number will change. That's the only difference. So I'm going to use this formula to solve some of these questions. Suppose you roll a number cube. What is the probability that you roll an even number? Well, we already established that how many sides are on a number cube?
6.
There are 6 sides to a number cube. So probability that I roll an even number. Whatever I write here in parentheses is my goal. I want to roll an even number. That is my favorable outcome. Okay, well, how many total outcomes are there? 6, so that goes in the denominator because that's my total possible outcomes. And favorable will be how many even numbers there are, and how many even numbers are there? 3. So 3 over 6, 1/2. And that's my answer. I box in 1/2. Make sure you reduce it. Okay? So whatever I'm testing, whatever I'm going for, that goes in parentheses. Favorable over possible, and then reduce it. Think you can do one?
Yes.
What is my probability that I would roll a number greater than 1? Write it down on your notes. So, on a number cube, how many numbers are greater than 1? 5. So, 5 over 6. See how that works? Okay, one more. Probability that I roll a 3. Okay, so again, my total doesn't change, but what's going to be my favorable? How many 3s are there in a number cube?
1.
1 over 6. All right, any questions on example 1? Any questions? Pretty good? Not too bad? Okay, so that's theoretical probability when the total can be predicted, and I know the total. Now let's talk about experimental probability. Still, I'm looking for the probability of an event happening, same thing, except now it's number of successes over number of trials. Technically, this is still favorable over total, right? Success, favorable, okay, it means the same thing. The only difference between the two types of probability is with experimental probability, the total cannot be predicted. And you'll see that in the next example. All right, so here's our example, miniature golf. A miniature golf course offers a free game to golfers who make a hole-in-one on the last hole. Last week, 44 out of 256 golfers made a hole-in-one on the last hole. Find the experimental probability that a golfer makes a hole-in-one on the last hole. So here's why this is experimental probability. At the beginning of the week, could the golf course manager say, I know without a shadow of a doubt that I'm going to have 256 people play miniature golf this week? Is there any way of him predicting that? No. From week to week, that number is going to be different. Do you see how that's different than a number cube? You know it's 6 every time. With this, your total will change. Okay? So what probability am I going for? What am I looking for? Probability of what? Making a hole-in-one. Making a hole-in-one. So it's still successes or favorable over possible. Okay, so go ahead and write that ratio. What's my ratio? 44 over 256. You'll want to reduce it. What does it reduce to?
11 over 64.
Okay, now in terms of me actually understanding what this means, a fraction doesn't mean a whole lot. Okay? A decimal would make a little more sense to me. Go ahead and change it to a decimal. Okay, so 0.17. Can I write that as a percentage?
Yeah.
17%. Does that mean a little bit more? Yeah. Okay, so guys, any one of these 3 answers would be acceptable on a quiz or a test. But when it comes to, actually making an answer practical, which one of those makes the most sense?
17%.
Yeah, the percentage. So if I'm the manager, I think, okay, well, I'm offering this promotion. Let's think about it in terms of profitability. Do you want to offer a free game to every person who plays golf if the probability is 100% of them making a hole-in-one? Why? Because then everybody who plays golf is going to be playing golf for free, right? They're going to have 1 ticket ever, right? And if they for sure can make the last hole, then they get a free game as many more times as they want to play. You're going to go out of business, right? So you don't want it to be 100%, but what happens if it's 0%? Is the promotion, does it really do any good? No, the people are going to be like, hey, that promotion is so rotten. They say they give you a free game, but it is literally impossible to get a hole-in-one. Like, not a single person ever gets it. Do you see what I'm saying? So we can use probability even in the professional workplace, in this type of example. Make sense? Okay, experimental probability definitely plays a role when you're talking about the business world. So interpreting probabilities. Let's go back to, our example that we used at the beginning of class about car accidents. If we know that the probability is 0, and we talked about what we can do to reduce the probability of passing away in a car accident, seat belts, not driving impaired, not driving distracted, driving the speed limit, all right, our probability of that happening is greatly diminished. However, if we are irresponsible, the probability shifts in the other direction, correct? All right, so we can use this spectrum to determine whether or not a risk is worth taking. All right, so this just kind of helps us. You don't have to write this down, but we use probabilities to make predictions about what is going to happen. Okay? I can't know for sure, but I can use probability to help me make those decisions. So let's look at example 3. I'm going to use the probability to make a prediction. Today I attempted 50 free throws and made 32 of them. Use experimental probability to predict how many I will make if I attempt 75 free throws tomorrow. So the first thing I need to do is I've got to find that decimal value of the probability of my free throws today. Okay? So go ahead and find that value. Right, so again, it's favorable over possible. Probability that I make a free throw. Remember, you have to have something written in parentheses. What are you experimenting? Okay, what is your goal? Okay, well here it's that I made a free throw. So favorable over possible equals what decimal value? You already said it. What is it? Now you can say. What is it? 0.64. Now I can use that decimal value. That is not my answer. But I'm going to use that decimal value now to predict what happens tomorrow. 0.64 times my total for tomorrow tells me that I'm going to make, if I make the same ratio, I'm going to make 48 shots tomorrow. All right. Now let's talk about odds. With odds, okay, all outcomes are equally likely. The ratio of favorable to unfavorable is called odds in favor, and unfavorable to favorable is called odds against. Here's what I'm looking at here, okay? Are my chances of something happening better than it not happening or the other way around, okay? So, for example, I'm not looking for the total. I'm looking for how does it play out against the outcome that I don't want. Let's take jumping off the house, okay? Jumping off the house for an example. If I'm standing up on top of the house, hopefully you have never tried this, and please don't ever try this. You're approximately 8 feet off the ground. If I jump off this house that is approximately 8 feet off the ground, what are my chances of breaking a bone versus not breaking a bone? Odds in favor over odds against. That's kind of what we're looking at. Playing the odds. You see that in, roulette, that type of. All right, so we're playing the odds. I want you to write down these two formulas, odds in favor and odds against. All right, so here's how this plays out. Okay, let me get to example 4. All right, it says, suppose you randomly choose a number between 1 and 20. What are the odds in favor of choosing a prime number? All right, let me backtrack real quick. There's one other thing I wanted to talk to you about. Notice, you say, how is it possible to keep these straight? Because what's going to happen is you're going to get confused. Oh my goodness. Okay, I'm looking for odds in favor. Which one goes on top, favorable or unfavorable? Think about it this way. If you're looking for odds in favor, favorable goes on top, unfavorable on the bottom. If you're looking for odds against, unfavorable goes on top and favorable goes on the bottom. All right, so does that make a little more sense? So odds against, then unfavorable is going to be on top, favorable will be on the bottom. All right, so now let's look at the example. So you randomly choose a number between 1 and 20. What are the odds in favor of choosing a prime number? So odds in favor, that's the one that I'm using. Odds in favor equals, which one goes on top, favorable or unfavorable? Favorable, because I'm looking for odds in favor. So now I have to figure out how many prime numbers are between 1 and 20. Well, let's list them. 1, 2. I'm sorry, 1's not prime. 2, 3, 5, 7, 11, 13, 17, 19. 8 numbers are prime. Okay, so that's going to be prime over composite. 8 numbers are prime. How many numbers are composite?
12.
How'd you find 12? You subtract 8 from 20, right? Because it does need to make up the total. So you know that 12 numbers have to be composites, either one or the other. And now you reduce it to 2/3. See how we did that?
One composite? No.
It's neither.
So then.
It's not prime. No, it's not prime. It's not prime. Technically, just assume that it's composite. Okay? All right. It's got to be one or the other, so we'll just assume it's composite. All right. Now it says, let's look at B. What are the odds against choosing a prime number? So now if it's odds against, what goes on top? Unfavorable over favorable. Odds against a prime number. So if it's against a prime number, unfavorable would be the composite values over the prime values. Do you see that? 12 over 8.
1.5.
Don't make it a mixed number. 3 over 2. I want you to answer C. All right, so now odds in favor or against? Odds in favor of choosing a number divisible by 5. So a number divisible by 5, how many numbers are divisible by 5? 4. So that's favorable. So if there's 4 numbers that are divisible by 5, how many aren't? 16, 1/4. Okay? Odds. Odds are favorable versus unfavorable. We're not dealing with totals. All right, guys. If you understand that, it's everything you need to know for 6.7.